Now we start SFD. Okay, so again, if I start the SFD, so I will repeat the whole questions again like BMD. Okay, so again we start from simply supported beam. Okay.
We'll do the BMD with it, right?
Yes. Okay, so for example, this is your uh, this is your you can say beam, and this is your BMD. Am I right? Okay,
Yes.
so and this is its SFD. This is upward, this is upward. It makes the structure up, and this force make the structure down, and this again the structure makes up. Okay, so this is SFD. Okay,
Yes.
so again I do another example. For example, this is your beam, and now the BMDs will be like that. Okay, and in this case the
Yeah.
BMD SFD is, it goes up and there is no force, it goes down and there is again no force and it makes it up. Okay,
Okay.
uh now for example, there is a cantilever beam. Okay, and it has a force at the tip. So what is the BMD? BMD is this, like, am I right?
Yes.
And how how its SFD will be like that. It make the structure down. Okay, and there is no horizontal, there is no force, and there is a AY. Okay, which make it up. Okay, so must remember that SFD has a 0 values at its end. Okay, so again I do another
Is
example
the
like that.
oh, sorry, 1 second. Is this considered to be 1 second? Let me just try to highlight. Um, is this considered? This is 100% negative, but this negative as well or positive?
Yeah, this is positive.
This
Actually,
is positive.
one thing remind that SF the value of SF the value of positive SFD and BMD is SFD or negative. It has no effect. But now you see that you should start from the left. Okay, so it is up. So again, it is positive.
It's because
Okay.
I usually for this one I usually draw it like this.
Yes.
The SFD.
Yes. You are right. So this is positive.
Okay.
You are right. So again, what will be the bending moment of this structure? The bending moment is like that. Am I right?
Yes, parabolic.
Parabolic. And the
Sorry,
BMD,
no, is it not meant to be linear?
it is a
Oh, this
BMD.
is bending moment. This is a BMT. Okay, okay.
Yeah,
And then
okay. And
for the SFD linear.
is it, is this right or is this right?
No, no.
A or
Yes,
B?
this is correct. B.
B. Okay, that's great. Now, yes, great. Now again, come to our little bit difficult part. Okay. Okay. So first of all, I just make a BMD. Okay, so you better understand how the BMD will be made. Okay, uh,
Okay.
you should make the BMD diagram on your mind and see that am I make it right or wrong. Okay,
Okay.
am I right or wrong?
It is correct.
Okay, now for SFD you just need to draw like that. There's a upward force, there's upward force, and there's a upward force. So how can you draw the BMD, SFD, sorry? Just like that, you have to make points. Must remember to make points, okay? It will be
Mhm.
more easier for you, okay? And now change the color. So first of all, it makes the structure up, and from this there is no horizontal force, it makes your structure goes down. Okay,
Yeah.
again there is no horizontal force, it make your structure up, and again there is no horizontal force, it make your structure down, and this
Yes.
makes structure equal to 0.
Yes. Yes. That's correct.
You understand this?
Yes. Yes. I
Okay,
understand it.
one, there might be another case of this question. For example, we can draw this bending moment SFD like that. This, 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 this,
It depends on the
this.
load, the
It depends
kilonewtons.
on this load.
Yes, but they're both correct.
Yes, both correct. But if, but you should follow this type.
Okay.
But in BMD, values are doesn't so much effect, because we have to consider the sagging effect and hogging effect.
Okay.
Do you understand this?
Yeah. Yeah.
So again, see some more examples. Mm, I think SFD is easy for you. Am I right?
I think I understand SFD more. I used to understand SFD more than BMD.
Yes. Now it's your time to draw BMD as well as SFD of this structure. Now it that's your test.
Can you go down a little bit, please?
Okay.
Yes, that's fine.
So
So
it's up. It's your choice. Either you make uh SFD first or BMD first.
this is negative, positive, negative, and then this is gonna be hugging, so it's all negative, this section. So for the BMD, it's gonna be like this, linear. Um, one second. Just let me 1 second. Um,
If you want to if you want to draw this diagram on paper and send me through WhatsApp, I can check it. I think it is easy for you. And if you want to make it here, that's your choice.
like this, and then there's UDL, so it's gonna be parabolic. Um, I remember here what to do. Um,
Now uh, see that here there's this force which make the structure down.
yeah.
Okay, but here there is no force which make the structure down. Okay,
Hmm.
so the BMD will be like that, 0. There is
Oh,
no
so
BMD here.
there's nothing here.
There's nothing here. Why? Because there is no force here.
Okay.
It is just a baseless. Okay.
But I think in the earlier
Yes.
you said that I have to consider it. No?
because there was a force here.
Okay.
Yes.
Okay. Can you,
And
if you can erase the,
might be there was some sort of other sports, that because when I was giving trying to teach you this example, I omit, and I make the different sports condition.
yeah, yeah,
So
yeah.
now do you understand this?
Yes, yes.
Now erase this and makes a bending moment SFD. Okay.
What?
Good.
Oh,
Yeah.
yeah.
Do you now you see that there is no shear force here?
Mm.
Okay, and there's no movement here as well. So when you
Yeah.
draw SFD and BMD and just see a little bit on both of them, you see a relationship between both of them. Okay, do you understand
Okay.
this?
Yes.
Now I think now you understand betterly. Just erase this, and I will give you one or more examples of
Okay.
make SFD and BMD.
For this one.
Yes.
So in this case, it's gonna be so this is negative, positive, right?
Yes. Okay.
Then it continue. No, but this is one. I'll draw it again. Sorry. Oof, and then it stays here. So negative, positive. Then for the BMD,
Brother, which force make it uh positive?
so like I was thinking maybe there is a moment here, but this is for the BMD. It will show in the
Yeah.
BMD, not in the deflection.
Yes, yes. No, no,
So
you
it's
you
gonna.
said that this is a positive.
Oh, this one.
Yes.
Oh, I was thinking because because I could be wrong, but it's because you said that if there is a roller or a pin in the middle, so
Yes.
it has some moment, so it will.
Yeah. Yes, it has some movement, but I said that you said that there's a positive moment here.
Oh, sorry. I meant negative. It's still
Yeah.
hugging. Sorry,
Yeah, it experienced a whole negative.
hug. Yes. Sorry. Uh, so in this case, it will be like oh, so it's gonna be parabolic from here. So like this. then stops here, and then goes like this, and then goes like this.
Yes, that's great.
Is correct?
Yes.
And then
Now,
for the SF,
now the BM SFD.
so for the SFD, it will go like this. This. It goes up again. And then here we have a UDL, which would be linear, which is like this.
Can you think again?
Sorry?
Can you think again and start from this position? Start from this because it has a load. Yeah. 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 That's it. Why you don't draw this up and like that?
The thing is, it depends. In situations like this, it depends on the value, right?
Yeah, it depends, but in this case, I don't think so. It depends.
Okay. But
Okay, let
I was thinking,
yes.
so for the first one, when I drew it like this, why was it like when I drew it like this? Why was it wrong?
Again, draw. Yes, just try.
And then I put it up because of this, and then here it's going negative slope. Sorry, negative slope. So it makes it shows that it's negative. And then this is
Actually, actually, the way through which I have explained to you, uh, it is better to that this is it make the structure. See, okay, your answer will be on this point. Let us erase this. Let us erase this and make a BMD for this. Oh, one sorry. Oh,
because I remember when we used to do this, if
yes,
it's a
make
negative
this.
slope, it's fine.
Yes, just make this. Make for this. It is
What
not just
BMD?
like SFD.
SFD.
It's just
Okay. So for this one, it's gonna be if my way or your way.
I think it is much better to follow my way because
So okay, in your way, it's gonna be
this.
straight like
Yeah.
this, up, up,
Yes.
then.
Yes. Okay, that's great. So I think we should erase this, and I will give you one of more examples related to uh, frame as beam, and then we should go towards frame because frame is little bit difficult.
Yeah, for me, even frame, I was. This is why I wanted 2 hours because frame, I'm not that confident in. I feel like I have more problems with it.
Okay. Make this SFD and BMD both. 1 minute. Yes, make this.
So in this case, it would be is negative. Oh, sorry. Sorry, my bad. Like linear. And then this is straight line, straight line, linear, straight line. Is correct?
Uh, Brother, is this a positive movement or negative movement? Why you draw negative?
Oh, so in this case, would it be? Oh,
If you draw lines, maybe you can draw better, like these
it,
lines.
I was thinking maybe it would be like this.
No, brother, no. Okay, let me draw the lines and you have to
Oh,
follow
yeah.
the lines. Just make
Okay.
erase it. Okay, just give me a minute. These are the points and you have to follow these points. Okay. Now draw
Okay.
the
So okay.
first you
So
need to draw the BMD and that's SFD.
okay. So it's gonna start like this. Is correct?
Yes.
Linear. Then we're gonna have parabolic. It's gonna go,
Yeah, great.
and then it's gonna be linear again. So it's gonna be um is it like this? Straight linear.
Why, brother? Why? What I have told to you that what does this positive mean? What this positive mean? Why I have written this positive and this negative, this positive, this negative? Because it shows that this is positive movement.
Yes, yes, yes.
It's
But
negative movement.
in my head, when I draw it like this, it's like as if it's going upward, so it's positive technically. It's wrong then.
Yes. So it will be like that.
Oh, okay, okay.
Have you
But
noted
it
out?
ends like this.
Yes, because the end is zero. Okay. Let
Yes,
me
yes.
just erase this.
Okay,
And you should make the SFD. Then again, I will give you another example.
okay. Um, so for the SFD, it would be like straight line upwards, then goes here, then negative, then goes here, and then upwards. assuming, yeah, and then
Yes.
it would have UDL, so it's gonna be um linear like that, and then upwards.
Oh, brother, no, no, brother. You
Oh
just
my bad. Sorry.
just make it just clear it.
Okay.
I hope you will not do any mistake
Sorry.
of this. I said that I hope you will not make mistake.
I hope so as well.
Follow these lines, okay? Make SBMD.
BMD. Okay, so it's gonna deflect. So it's gonna go like this, and then this. Oops, sorry. No, this is not negative. Actually, no, it's negative. It depends on if this is negative. Um, um, negative.
Yeah, that's great.
It's correct.
Yes, that's great. Congratulations. Now make its SFD.
So,
Better to start from freehand.
okay.
I think it's a better to start. Mm, but I think for this case, the bending, the SFD will be like that, okay? Uh, like that, this like that. Why? Because the moment is negative as well as so the shear force will also negative.
Okay.
You understand my point?
But would it be possible to be positive as well?
No, I don't think so. But it's not the case because
Okay.
it's a let me give you an example of this like that. Just erase that. For example, this is your where is my pen? For example, this is your cantilever beam. So this is your BMD. Okay. So your shear force is also, but yeah, it depends on value. Because I have told you that some in some book it will be positive, and in some books it can be negative. So it doesn't
Okay.
have it had those it doesn't have some you can say effect. Okay, so I think we should
Alright.
now start the frame, actually, because frame is little bit difficult to understand. But if you truly understand, and at the end of lecture I will give you a very simple you can say software which you can download on your PC and make different kind of frames, beams, and through which you understand more, and you can practice more about frames and beams. Okay.
Okay. Yeah.
Okay. So in normally in beam we only draw two diagrams. The first one is SFD and the second one is BMD. But in frame you need to draw three things: SFD, BMD, and AFD. You know SFD, BMD, but what is AFD? AFD is a axial force diagram. Okay,
Mhm.
so let's suppose we have a frame like that. Okay, and it has a point load on here. So can you tell me, is it determinate or indeterminate?
It is determinant.
It is determinate because two reaction and one. Okay,
Three reactions, three equations.
so do you know that in if the ruler is at the end, what I have told you that it always the moment is equal to negative. Okay, here moment
Okay.
is negative, here moment is negative. Okay,
Mhm.
so again, if this is a straight line. Okay, okay brother, one thing I want to tell you before starting the frame. To truly understand the beam, you need to uh, you need to actually understand the concept. But frame, but for understanding of frame, you have to somehow you need to learn few things. Okay, do you understand my point?
Yeah.
Okay, yeah, because sometimes you don't truly understand how this is going to positive, how this is going to negative. So if you memorize three or four different examples, so then you can make your by your own. Okay, so first
Okay.
of all, you see that, for example, I draw it again because it is little bit difficult to, it is not difficult to understand, but it is, you can say, complex. Okay, for example, this is your frame, this is A point, your B point, C, and D. And do you know that point D is is a pin, so it has a moment of 0, and point A, it has a moment of 0 because it's a pin. Okay,
Yeah.
and this is your uh this is your uh what's your point load. Okay, so there is, if you see from here, there is no horizontal force. Okay,
Yeah.
so uh to make the SFD or BMD of frame, you need to actually uh, you need to estimate the reactions. Okay, for example, now I give you a example. Okay, for example, this is your frame. This is A, this is B, this is C, this is D, and it has a force of, let's suppose, 50 kilonewton.
Okay.
Okay, so can you estimate what will be the reaction of AY and DY?
Um, 25.
25, 25, great. And do you know that what will be the value of AX? Can you estimate?
0. Oh,
0.
yeah, 0.
Yeah,
Because
0.
there's
Why
no
0?
horizontal force. No
Horizontal force.
horizontal force.
And here dx, because there is no dx.
Yeah. Yeah.
Okay. So now you see that for this frame, moment at A is equal to 0. Why moment at A is equal to 0? Because it is
And
pin. And B is equal to 0. Why? Because this force, because as I have told you that moment is equal to force into perpendicular distance.
yes.
Okay, so if you see the point B, this force has a value, but it has no perpendicular distance. Okay, again this value is B, and this value AX is equal to 0, so MB automatically equal to 0. Do you understand this? And
Because so you're saying because there's no moment at A, so B will have no moment.
yes, why? Because this force has a value but it has no distance, and this value has no force, zero force, but has a distance. Because what is moment? Moment is equal to force into perpendicular distance. Do you know perpendicular mean? This is perpendicular.
Yeah. Yeah.
Okay, so what is the value of MB? 0. The same way
Mhm.
moment at C is equal to 0. Okay,
Okay.
now draw a PMD of this structure. Again, you need to first make the deflection diagram. So do you know, it is somehow, you can say it is somehow a fixed end. Okay,
Okay.
it is somehow a fixed end. So how it will be deflect? It will be deflect like that.
So when I'm doing it, usually would I assume that it's always fixed?
Yes, in frame,
Yes.
the intermediate joint are considered as a fix.
Okay.
But for this case, For this case,
but wouldn't this have a actually never mind. Yeah, that's correct. Okay, I understand.
okay. So, but now for this condition, due to this A and this B, the moment at A is equal to 0 and B equal to 0, so this joint is don't considered as a fix, it is considered as a pin.
So basically, you're saying that because there is no more. So let's say A is fixed. So
I
that
will, I will, I
way,
will, I will, I will, I will make, I will go
sorry.
slowly, 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 slowly. Okay. So, are you writing somewhere these notes?
I'm taking picture of it.
Oh, that's good. That's good. Now, in this case, point B and point C is acting like a pin. Why? Because at B at C, the moment is equal to 0. Okay.
Mhm.
So tell me now, is this is sagging or hogging?
Sagging.
Sagging. So this is the bending moment diagram of frame. Simple. Okay.
Okay.
Now come to SFD.
Well, one second. You're recording this, right?
Yes, I am recording this.
Can I? Is it fine for you to send it after?
Yes, yes, I will. I will try to make. I will send you by anyway
Okay.
by Google Drive.
Okay, yeah, that's fine. Whatever, it's fine.
Okay. So now come to SFD. Again, draw this force 25 and this is 20. Sorry, 50. This is 25, 25. And this is equal to 0. Okay. Must write this line. Okay. And memorize this line. Okay. What is shear force? Shear force is the vertical perpendicular force. Okay.
Okay.
What is shear force? Shear force is a vertical perpendicular force. And
Yeah.
what is axial force? Axial force is along the force. Okay. Now, for this frame, you see that it has four ends, four members: member AB, member BC, member CD. Okay. Now, tell me for member AB, which force is perpendicular force? 25 or 0?
25.
25 or 0? Which is a
Zero.
perpendicular force? 0. So let me draw a SFD here. Okay. Oh, I'm sorry. Okay. So from A to B, the shear force is equal to 0. Okay. Now
Okay.
come to point B. Do you know this force when it goes up? Okay, one thing remind that in frame you are you need either you just need to memorize the different frames SFD and BMD, and you have to actually see the how the forces will flow. Okay,
Yeah,
you have flow. Now see that how these two forces when they reach at point B, how they will be affect. Like for example, this 25 is going up, and here is 25 because there is no resisting force. Similarly, it will go up. There is no, it is zero. Okay,
because it's zero. Yeah.
so yeah, so one thing, 1 minute, just change the color. Okay, so now tell me for BC, for BC, what is the perpendicular force? 25 or 0?
For BC, the perpendicular is going to be 0.
No, it is A 25.
So, but no, for A, it was 0. Is this correct?
AB. For AB, the perpendicular force is 0.
For A.
But what? Because
Okay,
this is
yeah,
a
yeah, yeah,
you
yeah.
have to see
Sorry,
the
sorry, yeah, yeah.
perpendicular.
My bad. Yeah, for BC, it's 25.
Yeah. So it goes up 24, and again there is no force, and again this is 50. So 25 minus 50 minus 25, and there is no force. Okay. So do you know this force? It goes up,
25.
25, and this force makes it up, and it will be 0.
Yeah.
So now come to point CD. For CD, is there any perpendicular force available here?
For DC, there's 0.
D 0. So this is the final SFD.
Okay.
Now draw a, sorry. Oh, I'm sorry. Oh, now draw the AFD. What is AFD? What
Axial.
is axial force? And what is axial force diagram? Which is acting along. Okay. So now tell me for AB, what is the axial force? 25 or 0?
25.
25. And it is actually it is up. So upward is always a compressive. So it is a negative. Okay, just remember that. So it is again 25 minus. Now tell me for BC,
0.
what? 0. So this is 0. For CD,
25. Negative.
25 minus negative 25. Okay, again in BMD or AFD, signs affects, or you can say it is very compulsory. But for SFD, sign is not so important. Okay, now
Okay.
come to another example. 50 again. Now tell me, is it determinate or indeterminate?
Indeterminate.
It is indeterminate. Okay, so
Yeah.
if your structure is indeterminate, okay, let me, what is this is A, this is B, this is C. What is AY? Okay, let's make it 60.
It's
Okay,
25.
let us make it 60. Let us make it 60. Okay, what is this?
30. 30. 0.
No, it is not a zero. It has some value. Okay, this concept you have to understand, because when you are solving the indeterminate structure, always there is a some value. Okay, so you don't need to actually finding the real values. You just assume this value. For example, this value might be 10, but if this direction is this one, so the in this way this direction is 10. Okay, do you understand this?
Yeah. Okay.
So the arrow in this case, let me draw it better. Okay, so in this case it will be like that. Okay, so first of all we will try to make SFD BMD. Sorry. Okay, you can also make first of all you can make the deflection diagram. Okay, so it
Okay.
this is somehow the deflection diagram will be like. Okay, okay, so now tell me, here from here you can draw. Okay, what is the movement at A?
Um,
0.
0. Yeah.
Why? Because
But,
it is pin.
yeah.
What is MD? 0. But MB, there is some
Also,
value.
I for a second I thought this is fixed
Yeah, yeah, this is not fixed.
10. Okay.
If
Yeah,
it
0.
is fixed, it has moment.
Yeah,
It
yeah.
and
This
what
is why
about,
I was confused on you're asking if what's the moment, so I didn't know what the moment was
yes.
for.
So what will be the MB? So you can assume what will be the moment at MB. I thought it has some value or 0. Tell me.
0.
No, it has some value, because this AX makes some value.
Gonna be negative
This,
AX.
yeah, it can be. Let we will see that what is will be. So you can say that this distance is equal to 1 meter. So MB is equal to 10 meter, 10 kilonewton meter. And again, moment at C is equal to again 10 kilonewton. Now we know that the point A equal to just a minute. Chat is now. Okay, uh, this point is equal to 0, this point is equal to 0, and this point the moment is equal to 10, this point is equal to moment is equal to 10. Now come to the concept of deflection diagram. So
Sorry,
now tell
sorry, one
me.
second. I'm confused now about something. So for you said that the moment at A is 0,
Yes,
but the moment at B is 10.
yes,
But is this because
because of AX.
but how come for the moment in A we did not consider BX?
Px, actually, this is a pin sport. What I have told you to that pin sport is unable to take any moment.
But this is pin as well.
B?
No, here. This one.
Yes, again, this moment MD is also equal to 0.
Oh, I thought that you're saying that the moment 10 is
I'm
for
talking,
D. Oh,
no,
okay,
no,
my
I am
bad.
talking 0, 0, 10, 10.
Okay.
Okay.
Yes, okay.
Now, now tell me this section is experiences positive moment or negative?
Um, it's experiencing sagging. Negative.
Sagging. Positive. Sagging is positive, brother.
Positive.
And what about this? This is negative and this is again negative.
Yeah.
Okay. So this will be make like that. Okay.
Yeah.
Okay. Now remember this sign. If this is on the downside, so the next value should be started from here. So it will be like that. 0. Straight line. Okay. Do you understand this?
Does it usually start from here, like from where this ends?
Yes, if yes. For example, if it ends from down, then you start from this position. For example, if the movement is like that, up, then you should start from right, from left. Okay?
Oh,
So down, down, right.
okay.
Okay? Let
Yes.
me try remove it. Let me try it more clearly.
Removed.
Okay?
Yeah.
Now just remove this.
Remove what?
I'm sorry, erasing it. Just give me a minute, I drink water.
Yeah, of course.
Okay, brother. Now tell me for AB, which force is I'm talking about SFD, okay?
Okay.
Which force is perpendicular force? 30 or 10?
For what? AB?
Oh, 1 minute. Sorry. 30 or
For
10?
what? For what? AB?
Yes.
It's 10.
Great. Okay, this is done. And for BC, What is the value of, what will be the perpendicular value?
Perpendicular value would be 30.
Great, great, brother, great. And now tell
And then
me
here
which,
30.
and again this is 10.
Yes, 10, exactly.
Great. Now I am drawing uh, axial force diagram, okay?
Okay.
What is the axial force diagram? AB. Let me change the color. What is the value?
10.
Axial force, brother.
Um, oh, sorry, 30. Yes,
Side
30.
30. And for BC?
It's gonna be 0. No, 10, 10, 10.
No. 10. And for BD?
It's for B for BD, it's gonna be 10.
Sorry, CD.
For CD, it's gonna be 30.
30. Okay. This is minus, and this is positive. Do you know why this is positive? Actually, it when it go up, this is this way and this way. So the you can say the right, if the force is in right, and it will be up, sorry, it's up and down. So it is like a, no, it is again down. Okay, how I understand, how could I understand this is down, negative? Because actually, see that, let me give you a concept. Okay, see that this is minus 10. Okay, it goes up. The resulting value is always opposite. Okay,
Mm.
the resulting value is up always opposite. Again, this is going up, and the resulting value is now these two forces make this structure compress. So the compression is always negative. The similar way is like that. It make the structure compress.
So the 10 on top, is it positive or
Is a
negative?
negative because it is making the structure compress.
So why was it 10 on top?
No, it is my mistake.
Oh, okay. Okay, now I understand.
Okay. So again, we are coming to another example. Let's suppose this value is 80. Now tell me some approximate value of A,
It's
B,
fixed?
C, D.
Is this fixed?
Yes, this is fixed. AY is equal to 40. CD is equal to 40. AX is equal to, you can say, 20. And
Yeah.
DX is equal to 20.
Mm.
Now we can't predict M moment of this value, but it has some value.
Yeah.
Okay. Now again use the concept of deflection diagram. It is like that. Here there is a positive moment, there is a negative moment, there is a negative moment. Okay, so now draw the BMD diagram. Okay, I'm sorry. Okay, so start from the center. Is it like that?
Um, y-
Because
yes,
this is a positive,
yes,
this is negative, this is negative, again this is positive, negative. And again what I have told you, that if your bending moment is on down, so you start from the right. So you
yes,
are starting
exactly.
from the right.
Yeah.
Now just to remember that it will go like that, and it will not goes to zero, and this it has creating
Is it
some value.
is it because there's a moment?
Yes, this because moment. So only the difference between this one and this one is that it has a zero and it has some value.
Okay, okay.
Okay,
Yeah.
so the SFD and BMD will be the same. For example, what will be the SFD? Let me draw quickly. This is SFD and this is AFD. So this is your AF. This is your 20.
Mhm.
Okay, this is your 40. This is your minus 40. This is, and this is positive 40. This is 20.
Yeah,
This is
yeah.
your SFD. What is AFD? 40,
Yeah, yeah.
20, and
Still
again
pressing. Yeah.
40. Okay, it will here,
Mm.
right? Okay, here, because this is a negative region, this is positive region. Okay, must remember, this is negative region, this is positive region, this is positive region. Okay, and this is
Yeah,
positive region.
yeah. Okay.
Okay,
One
so
second. I'll take picture
now
one
come.
second. Can I take a picture,
Okay,
please?
yeah, yes, you can take picture.
Okay, yeah, that's fine.
Okay, now goes to another example of okay. So for example, now assume that it has some value, like this is 40, this is 20, this is 10, this is 30, this is equal to 0. So this will be the bending moment diagram.
But
Okay.
one second. In this case, it is
Yeah.
determinate.
Oh, oh no, no. Let me show. This is fixed.
This is fixed.
Yeah, if okay, if you don't
No,
if
I'm asking, is this fixed or pin?
yes, it is fixed. It is fixed.
Oh,
I'm
it's
making
fixed.
it
Okay.
fixed. Yes.
Okay.
If
I'm just
it is
making
not
sure
fixed,
because
yes, if this not fixed, then this is not equal to 10.
yes, exactly.
Yes,
I was
yes.
just making
That's
sure.
great. Yes, that's great. Okay. So MA, there is a MVA value. Okay. So again, this is your positive region because it will be deflect like that. Again, this is negative region, but this is positive region again. Why? Because this moment equal to 0. Do you understand?
Hmm?
Let me draw this again more clearly. Now you have to mm, you have to merge your above concepts, two concepts which I have given you
Okay.
separately, and
Okay.
these two comes, and I hope so you will quickly understand,
Okay.
because it is not as difficult and you're giving so much good attention. Just give me. This is your AB. This is fixed. Okay, and this is your, and this is a small. So for example, it, this value, it's 30, this value is 10, this value is 5, this value is 8, and MA has some value. You can say this value is 2. So but here MA, MB, MC, MD. So do you know that MA, MD is equal to 0?
0. Yeah.
Okay. So I'm making the bending moment diagram. So tell me if I am wrong. Okay. I am making bending moment diagram. If I am wrong, you can tell me.
Okay.
This is bending moment diagram. So tell me, am I right or wrong?
1 second. It's correct.
Yes, it's correct. So what if, okay, uh we do another example. Just give me a minute. And now I am drawing and draw a shear force diagram. Okay. So for the shear value, this is 8, goes up, and this is 10, this goes down, again this come up.
Mhm.
And the for CD, the shear value is equal to 0. Am I right or wrong?
The shear value is equal to 0. 1 second.
For
Um,
CD.
1 second. Let me think. Shear value. Um, yes, it's 0
Yes. Why the 0? Can you tell me why
because
0?
because it does not have a horizontal force. It's a
Yeah,
roller.
that's great. Yeah, that's great. So now this is your axial force diagram. Minus 10, minus 10,
Okay,
minus
so it's
8,
8.
and minus 5. Am I right or no?
Correct.
Yeah.
No, 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 no.
Now,
Um, they no, no, one has to be positive, one has to be negative, or it has to be split, no? Okay, minus
which
10 and
one?
minus 5, as in they're both minus from the inside. Is this correct?
Yes, this is minus throughout minus. Let me draw it more clearly actually.
It's because earlier what we've done was when we were drawing it, we had one positive, then we had
No, no, that was shear. That was for shear, brother.
Right.
For the axial, what I have told you that for axial force, you have to see that either your section is compressing or it is going to away. Let me draw it again. See that this force is trying to make your structure compress.
Mm.
So this will be minus 10. Again, this is equal to minus 8,
It's 8.
and again it equal to minus 5 throughout minus 5. Do you understand this?
I'm just confused. I'll be honest with you. I'm just confused with the why it's -5. This one.
Which one? This minus 5. Actually, see, brother,
Why is it
it is
minus?
up.
I'm just confused on the sign convention.
Yeah, actually, this is upward. Okay. And do you know that the its reaction is downward? Always action and reaction are equal in magnitude but in opposite direction. So
Yes.
what
Yeah.
it tries to make, it try to make your structure compress. So the
Okay.
compression is equal to again it is negative.
Mm.
Okay.
Okay.
So now come to a little bit okay. So this is hinge. It is not ruler. It is hinge. Let me correct it again. Uh, oh, I'm sorry. It is this one. Okay. So you can assume some values.
Like,
So
so
that
yeah, the UDL is 40.
okay 40.
And then the fixed is 40. No,
So
sorry, 20,
this
20, 20, 20.
2020, and this
Yeah.
value,
And then here we can have it as
for example, if it is equal to 10, so it is 8 and it is 2. Okay.
yeah, yeah.
And this has some value. Okay. So now, brother, you have to little bit try to understand the concept to rotate your structures. Okay. So for example, see from this, from start from this, because it is a little bit easy. So
Okay.
first of all, you need to draw the, I draw here. Okay. I draw here. First of all, you need to draw the BMD, and for BMD, you need to draw the, what you need to draw the, actually, mm, first of all, you see that MA has some movement. A, B, C, D. Write on your mind. MA has some value like 20.
Yeah, yeah.
Similarly, MB has some movement. Okay.
Because A
Like,
has
yes, because MA has a movement as well as MA has a horizontal force. That's why
right.
MB has a movement. For example, it is 60. And again, MC has some movement like 40. And again, MD is 0.
Yeah.
Do you know why MC has 40? Because there is a force.
Yeah, there's a
Because
horizontal
there's a
force.
because there's a horizontal force. So
Yeah.
because this horizontal force, this is,
If there was no horizontal force, it would be zero.
yeah. the-
Okay.
no, no. Then no, no. Then might be. Yes. For that, then MC is equal to zero.
Yes.
Okay. Now, brother, you see that it is positive from the center
Yes.
and negative
That,
from the end.
yes. Yes.
Okay. So just draw here.
1 second.
Up positive and
Yeah, I'm just
negative.
making sure. I'm.
Trying to make, you are trying to make,
Oh yeah,
but
yeah, yeah. Sorry, I was just confused on why there was negative, but now I remember that it has a moment
yes, because there's a moment.
and there is a horizontal force. Yeah, okay, that's fine.
Yes, there's a moment force. Okay. Now, what I to have told you that if there is a negative moment here,
Yeah,
so it will start from this and it will
from
be
down. Yeah,
equal to zero.
exactly.
Okay. And for this, you have to draw the straight line here, and you start from this position.
Yeah,
Okay. And there is no force, there is no force of variation, so it will be go straight. Okay.
okay,
And
yeah.
then it goes like that. Did you understand this point?
So, it became parabolic because of the forces that were. So
No,
it
it's
was
no,
this
no.
bit
Yeah,
from.
no, this is straight, brother. This is straight because there is no force here.
So it's straight, and then why is
Yes, and
it
this
not?
is, it is a straight, it is a 1D curve. It is not 2D because there is like cantilever beam, brother. So it is, if it is a UDL, then it will become like that.
I think I get it. Uh, so
Do you
it
get
was
it?
like this.
Yes.
Okay, I think I get it. Yeah.
Okay. So I think for SF for I think you can easily draw SFD and BMD of this.
Mhm.
Now I am trying to make SFD and BMD and tell me where I am wrong. Okay. But in exam you don't, you just assume the value separately. You don't need to write the values on
Mhm.
internally. Okay.
Okay.
So I am making SFD. Okay. So which force is SFD is equal to minus 8. 8. 8 is going there. So 8. 8. Don't write sign, but you can write sign positive because it is on left.
Mhm.
Again, it is 20. This force is 420 downward, and this force goes made up. And this is your negative 2. Okay, because this direction is this one. Okay,
Mhm.
this is your SFD.
So, what would happen if, l- let's say, this was 30, and then this is 10 for the if I assume it like this. So,
Yes,
would
yes.
it if would it go
30.
like? But this is 10, so
Yes,
it would only go up 10.
yes,
Okay.
because it has to be made 0. Okay.
So, so you're saying that it would only go down 10, and then I put it up 10.
Yes, and this makes the structure 0.
Okay.
Now I am making AFD. Okay, so it is up, so it is negative minus 20 because it is making a compressive.
Eight.
I am one minute brother, I am making shear force is wrong. You did not take one force. 1 minute, 1 minute, 1 minute. Brother, see that uh for example, this is your uh see that this is your vertical force, my here 8. Okay, when it goes up, this 10 make it here. Okay, and it will be equal to 2, and then it goes up 0, and this 20 is goes up and then
Yeah,
goes
this is
down.
this is what I was um, confused earlier because it was like this,
Y- yes,
but it makes it that way. It would make it as if it was a uh,
that
it would
was,
be as if it's a UDL.
yes. Now do you understand the point?
Yes, I do.
Okay, so and at the last, what is the what is the axial force diagram? So axial is just minus 20, minus 20. Okay, and here the axial force equal to, now tell me what is the axial force of this point.
8 minus 8.
No, 2.
Oh, sorry, 10.
No, it's 2,
But how can I know?
because you have to make your summation of the forces. 8, when it's go up, it's 2. So from when it reach here, it will be 2.
Oh, okay.
Okay, and again, this is minus 8. My here 8, it here it's 2, here it is 2, but its reaction it will be that that's way,
So
and
okay,
this reaction
if
will
this
be that, so it will be up.
so if this was, let's say if this was 12,
Yes,
it will go up, and it's gonna go like here, and it's gonna be 2.
yes,
Okay, okay, got it now.
actually you have to summation of the forces. Okay, do you understand this?
Yeah, but this, but if a question like this, like if a question, let's say like this comes but with no values, if I put it here or I put it here, it's correct
Yes, you can.
because yeah, okay. It depends on
Yes,
how.
because depends on the value.
Yeah.
So but you can assume some of the values, but don't assume the value so blindly. For example, you can say that this equal to 40 and this is equal to 100 and this 100. You can say little bit. You have to make your structure equilibrium. Do you know what does equilibrium mean?
Yeah.
Yes.
But how can I
So
make sure that it's equilibrium?
you can make your sure your structure is equilibrium like that. For example, this is a question 40, 30, not it's not right 40, but it's just like that. So you can assume this 30 and this equal to 15, this 15, and you assume
Oh,
that this
okay.
is 15, then it should be, if this is 10, then this also equal to 5.
Okay.
Okay, you don't say that this is 15 or
Okay.
25.
Okay.
Okay, and the last thing is that sometime, uh, for example, this is your, and this kind of forces, this kind of, you have to, if your structure will be like that. Okay, so in this case you just need to memorize the bending moment or bending moment diagram. Okay, so it
Does it matter if the structure is like this or if it's like this? It's the same
no, no,
fixed.
yeah, it's same fix. Yeah,
Is
you
it, is
can,
it, is it the same thing?
it, no, it is different because it
Yeah, but
has, you,
the
we
question that I
can,
sent you was like this.
oh, we can we can understand both, brothers.
Okay.
You just need to understand that the bending moment will be like that. Okay, it will be this one direction, so it will be like that. Okay, and as it is right hand side, so it start from this, and as it is up, so it has this one and this one. Okay, so for now you just need to memorize these values. Okay.
Okay.
Okay, so this is your BMD. So now you can draw your SFD like that. For example, this has some value 10, 20, and this is minus 20. And now tell me, brother, if I said that this is 20 and I have said that this is minus 20, why this direction, why I took opposite direction 20?
Because there is no load on top.
Yes,
It's,
because there is no vertical load. That's great. So again, shear, and for example, this is 40, this is 20, and this is 20. So what is the shear? So how can you draw shear force diagram?
so it's gonna be up.
20,
Yeah, exactly. And
this,
then up, yeah, and then
and
here
this, and this 20,
20.
and this 20,
Yeah,
and there is no force here, 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 and it goes like that.
yeah,
Okay,
exactly.
and this 20 here be like that. Okay, so
Exactly, yeah.
this is your shear force diagram, and what will be the axial force diagram? So axial force diagram like that.
It's gonna be exact the same.
It's like exact like that.
20, yeah.
Okay,
Hmm.
so I think I have covered nearly all type of frames.
Okay.
Okay, so at the end, if you want to practice some question, I want to quickly give you an overview of a simple software through which you can easily memorize, and you can draw your own beams, frames, loading, and you draw the SFD, BMD, and AFD. Okay,
Okay, yeah.
okay, let me show you. Give you, this is the simple software which is named by Risa.
Is it for free or is
Yeah, it's a free. It's a free.
and with the software, let's say, does it give me all the like let's say if I put fixed and then frame and then would it
Yeah.
give me
SFD, BMD, AFD. It will give you everything. Okay.
Okay.
So maybe I try to give you this software by your email, because this is a simple software. What you need to do is you just need to open it in your PC. Okay.
Okay. Okay.
So does it is it looking?
Yes, I
Are you
can see
seeing?
it. Yes.
Okay. So brother, this is the simple software. First of all, what you need to do is you just need to open a new file. Okay. New file. I'm not. Do you want to wish? Yes. Okay. So this is your grids, and what you want to draw. If you want to draw beam, okay. So what you need to do is just go to the if you want to select your units like metric, imperial, you want any of you want to select, because now you just need to understand the concept of SFD and BFD, so you don't need to take any units. First of all, you go to insert, go to the joints, okay, and press F3. Okay. Let
F3
okay, F3 is actually, yeah, okay, F3,
on the keyboard.
F3, 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 F3. Okay, it is a joints like A, B, C, D. Okay, and you are giving C here. Okay, this is 0 0, this is 10, this is 18, this is 25, or this is, okay, for example, this is 18 and this is 25. Okay, do you understand this?
Yeah.
This is 10, this is and this has this different net. Okay, now what you need to do, go here and draw a member. Okay, and you just click OK. One member, one member, and one member. Now it's a time to draw the boundary condition. Okay, go to the insert boundary condition, and now it's up to you that what type of boundary condition you want to select. Okay, for example, this is a fix. You can select fix here,
Mm.
but one thing remember that, brother, fixed port never come at the at here, here, here. It only come here or here.
Okay.
Okay, so I can draw here, and here I can, sorry, insert, insert boundary condition, and I select here pin, pin. Okay, I just zoom it. Now what you need to do is, I am giving a load. For example, if I apply a load, point load here, UDL load here, and point load here. Okay, so you go to the view and go to the member label, so it is called member one. So what in member one, what type of load you want to apply? Point load. So you just
Point
go to
load.
a
Yeah.
point load, you go to the point load, again press F3. Now the direction of the force is y, and the value of force, whatever the value you want to select, for example 100. And what is the distance? For example, it asks the distance, so I want a distance of 5, for example, from this to this 5 distance. Okay, but the load is not looking, it's not seen, so you go to the view and just to the load. Okay, now it shows up. So what you need to do, just go to the point load and press here minus. Okay, now in M2, you wanna apply UDL load, so you go to the distributed load, press F3. What is that starting magnitude? Starting magnitude mean minus 20, and ending magnitude again minus 20. But here we have to select M2. Okay, so this is your, and If you want to draw a point load here, this is your choice. But if you just want to learn that if there is no point load, then how can I draw? So what you need to do
Mm.
is, first of all, just go to the solve. Question has been solved. So what I am suggesting you, first you need to go to the this. So brother, see this. This is deflection diagram.
Okay.
Okay. This is a great view of the deflection diagram. Okay. Now just again press it. It not will be shown. And that this is your bending moment diagram. Now it is little bit you are not looking. So you can view and you can say that I don't want to look load. So you can zoom. Okay. And see that
Okay.
how can be. Okay. So this is your bending moment diagram, this is your shear force diagram, and this is your axial force diagram. Okay. But I suggest you that you see that you can't see these values. Why? Because the value is so less. So when you try to solve the questions and you are not seeing what is right here, so you can increase the load, or either you go to the details and press this button, and like that it will clearly shows. Okay.
So let's
So
say let's say in a question like this, it comes in the uh, let's say it comes, but they I don't have any loads given to me. Would I just not draw anything in this part?
I don't understand your question.
Let's say a question like this comes, but because I'm telling you to in the interview they will not give me any values. So it's just
Yes.
be so. Would it be wrong if I just don't draw anything from any from this section?
Well, it depends. It depends what I have told you, that it if there is a sport here, you need to draw the first, you need to draw the deflection diagram. And if there is a sport, then definitely you have to draw the BMD if
Okay,
the movement is occurring.
okay, okay.
Okay. So now if you want to draw the frame, this is a again same way. Okay. For example, insert joints. I'm drawing a simple frame. Okay. A, B, C, D, 10, 10, 10, 10. Okay.
Yeah.
Okay. Okay. Okay.
Mhm.
Just giving you the example. Okay. I draw these two loads. And if you want to draw the again point load. Okay. So this is the type of load. Okay. So what you need to just go to the solve. This is your BMD. This is your SFD, and this is your AFD. Do you understand this?
Yes, yes, I understand. But does the software, so when it's So does the software usually, let's say if the point load was here, does
Yes.
the software just automatically assumes
No,
like
no, no, no. Software exactly calculate all the things. It, you can say it 100% is, they are 100% accurate.
okay, okay.
I'm not saying to use this software in your paper like that.
You know, it's
I'm
it's
just say
it's not
that,
no, it's I can't use this anyways because it's an interview.
yeah,
So it's
yeah,
if
yeah,
it's fake with camera.
yeah, yeah, yeah. So I'm just saying that you can practice your question from here.
Yeah, yeah, this is my plan. Hopefully I'll be working on it tonight.
Yeah, yeah. So for example, you just need to first see the questions that I have. You can say teach you during the lectures, or you can also take some questions from internet, like some books or some Google, and just set and try to make by your own, and then see that either you are making your uh, it wrong or right. Okay. And I also share one of my lecture from YouTube, but the lecture is Urdu. The lecture is in Urdu.
Yeah, that's
But
fine. That's fine.
if you see that, maybe you can understand some more concept regarding to draw the BMD and SFD of simple beams.
Okay. Yes, that's fine.
So okay, brother, now we should end the lecture.
Okay, yes, that sounds good. Thank you very much. If you can please send me the recording and if you can send me the YouTube video and this website, because for me the
Okay,
recording is very important because we went through everything and it's
okay,
very
okay, brother.
so I will go through it again and I will check this website. And if you can send me everything, I'll send you my email.
Okay.
Um,
Okay,
also,
brother. And now I just make some beams on paper. Okay.
yes,
And you are trying to make, because now it's nearly AM here and 1 AM here. Now I'm going to sleep. But if I was awaking, and just send me the questions on solve, and if there's some mistakes, I will answer you through to WhatsApp. Okay.
yes, that would be perfect. What time do you usually wake up early in the morning?
Well, brother, it depends, and because tomorrow I have no class, so well, again it depends. So, but
I'm just saying because if I feel like I need another maybe hour or two maybe before the interview, I was thinking because the
okay,
interview is at 10:30 my time, but uh, I will study today everything that we've done, but so if I wake up maybe 7 a.m. in the morning, which is almost one, I think your time, there's 8 hour difference, so it would be
okay,
like one p.m. your time.
okay. Maybe I will be available at that time.
Okay.
Okay. Now, brother, I will give you some questions of
Okay,
beams
that
and
would the more
frames.
questions you give me, the better. I will solve them all. This is
Okay.
my plan for
Okay.
tonight.
First of all, you just need to draw by your own, and
Okay.
then you can, if you want to use the software, you can check your software through your software, and at the end when you can say that you are 100% sure that your answer will be correct, then you can send me, if and I will check that. If there's some mistake, I will let you know. Okay.
Okay, that's perfect. Thank you very much.
Okay, brother. I have a one request for you.
Yes.
Just accept the offers from the Fiverr. Okay. I will mark that I will give. I have delivered a lecture to you. Okay. And please give me a good feedback in my Fiverr account as well as on my friend Fiverr account. Okay.
Yes, 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 of course. No, definitely.
So okay, brother. Best of luck for your interview.
Thank you very much. And I will contact you if I need do you
Okay,
by
okay,
any chance
brother.
I wanted to ask you a question. Do you teach structural design? Because I'm a
Yes,
third
yes.
this This everything that we've done today, I'm in the UK, it's 3 years course in civil engineering. I'm third year. I haven't done structure analysis in 1 year, and the last time I've done structure analysis was 1 year and a half ago. That's why I forgot a lot of it. But for structural design, it's a bit more complex. It's harder than this. It's third year and it's my final year, and I've been doing it for the past 3 years. Do you do structural design by any chance?
Y- Yes, yes, inshallah, brother. You don't worry about structural design because I have a strong grip on design of concrete structure as well as design of steel structure according to Eurocode because I have working since 3 years on in specifically Eurocode.
Okay. Okay, then perfect. Then I can maybe if I have any questions or maybe have lessons or uh, with you if I'm stuck in one because I will study it by myself. But if there's certain bits that I'm confused on, maybe I will get in contact with you.
Oh, okay, brother. Okay.
Perfect. Thank you very much.
Okay, brother. Thank you. And
Thank you,
just
brother.
remind me in Fiverr. Give me good feedback. Okay.
Yes, yes, definitely. Honestly, you're very, very helpful today. Thank you very much.
Okay. Okay, brother. Okay, brother.
Thank
Allah
you, brother.
Hafiz.
See you. Allah.